going to be Objective 19, we're going to factor using a difference of two squares. That's what it's called. And so I want you to think for a minute, what does it mean to be a difference of two squares? Subtracting, so we are going to be subtracting two things that are perfect squares, okay? And so when I say squares, I mean perfect squares. Remind me, we'll do a little definition, what a perfect square is. Or can you give me an example of a perfect square? 1, 4, 9, 16, 25. You've already done this year, right? We know the list, and we're going to go through the list in a minute. So how do we know that 9 is a perfect square? Because it's the square of a whole number. Okay, and that's what perfect squares are. They are squares of whole numbers. Okay, so let's review the list. Remember the list you had to write in under a minute? Okay, let's review our perfect squares from 1 to 20. Okay, Harvey started us off. 1, 4, 9, 16, 25. Keep rolling. 36, 49, 64, 81, 100, 121, 144, 169. Awesome. Yay. 256, 289, 324, 361. Awesome. Very good, though. Very, very good. Okay. How many have forgotten those? A lot of us, okay? But just reminding you, and that's the thing, the next bubble that we're heading into is radicals. Again, we're going to use the list, and if you're not familiar with this list, you're going to struggle come radicals, okay? We're going to be simplifying square roots, okay? So you need to make sure, but we are going to have, these numbers will be in our problems today we're going to factor using a difference of perfect squares. So you will see these. Are these all the ones that you will see? No, there's more. Like you could have 21 squared, which is 441. You could have 22 squared, which is 484, and so forth and so on. They go on up, but these are the ones under 400. These are the ones you most commonly see. You need to recognize, okay? For example, on your quiz, you had a trinomial that had 121 at the end. Do y'all know which one I'm talking about? And a lot of people looked at me and raised their hand and they said, Miss Corns, I can't find anything that goes into 121. Well, you should have remembered. Did anybody remember that it was 11 squared, that it was a perfect square? And it was 11 times 11, okay? And it does work. But a lot of people kind of struggled on that one to begin with because you couldn't find anything. You need to know these and have them memorized or be familiar with them, okay? So let's look at example 1. Now here's the question. Today we're going to kind of compile everything that we've learned thus far. Okay, how on the test tomorrow, if I say factor this, how do you know not to use a GCF? Because there's no common factor. How do you know not to use trinomials? It's not a trinomial. I love that question, right? How do you know not to use trinomial? Well, it's not a trinomial. It's got two terms. It's a binomial. Okay, how do you know it's not to group? It's not 4 terms. Remember, we group with 4 terms. So my question to you is, today we're going to learn a difference of two squares. Is this a difference? Are we subtracting two perfect squares? Is x squared perfect? What times what is x squared? X times x, the same number times itself, you with me, is a perfect square, even if it's a variable. So x squared is perfect. Is 9 perfect? Yes, so we are subtracting two perfect squares. So what we will do is we're going to work this like FOIL. First times first is the first part, which is what times what? X times x. Last times last is the last part. And before you had options. You could lay out your pieces 9 and 1 or 3 and 3. But I'm going to tell you this. If it's a difference of perfect squares, you don't have to lay out your pieces. You will always be using the square root of it. Okay? And I'll show you why you're going to use the square root of it in a minute. So what will we use for 9? We'll use 3 and 3. So we're going to use plus 3 and minus 3. And everybody says, will it always be the square root of it? Yes. Because if you check it, and this is your answer, by the way, you're done. One of the factors is x plus 3, and one of the factors is x minus 3. If we check it, how would I check this? FOIL, binomials. X times x, x times negative 3, negative 3x, 3 times x, positive 3x, and 3 times negative 3, negative 9. Now, if you look at your problem, first times first gives us the first part. Last times last gives us the last part. What happened to the oi? They cancel out. And that's why you have to use the square root. Everybody says, why couldn't you use 9 and 1? Right? You with me? If you use 9 and 1, would a 9x and a 1x cancel? No, you would end up with either, it depends on if you're adding or subtracting, you'd end up with either 10 in the middle, a middle term, or you'd end up with 8 in the middle with a middle term. If you want the outer and the inner to cancel, it's got to be the same number times the same number. Do you understand that? And one's positive and one's negative. That's why you're going to use the square root of it on these, because you need the middle to cancel. And someone said earlier, they said, is the middle always going to cancel on this? And I said, yes, because it's a difference of 2 squares. Okay, it's a difference of 2 squares. Does this have a GCF? No. Trinomial? Grouping? Is it a difference of 2 squares? Is 4y squared perfect? Well, times what is 4y squared? 2y and 2y. And someone said, why don't you use 4 and 1? What did I just tell you? In order for the outer and the inner to cancel, it's going to have to be the same number times the same number. Do you understand? So that the outer and the inner will match except opposite signs. Okay? And 25 is perfect. They're both perfect. Okay? So let's factor it. First times first is going to be 2y times 2y. Does everybody understand why we're not going to use 4 and 1? Okay? Because we're trying to get the outer and the inner to cancel. Okay? Last times last is 25, so I will use plus 5 and minus 5. Okay? And everybody says, do I have to check on these? I'd like for you to check so that you understand how that they do cancel. You don't necessarily have to do the first and the last. We know that 2y and 2y is 4y squared. We know that 5 and negative 5 is negative 25. Everybody agree? But let's check your outer. What does the outer give me? Be more specific. Negative 10y. What does the inner give me? Positive 10y. And when you put them together, they cancel. Does that make sense? Are we following along? Do we think these are fairly easy? Yes? Okay. If I said to factor this tomorrow, who has some thoughts? Harvey has a thought. What does Harvey think? Not at all? Do we agree with GCF? Now, here's the thing. Everybody, we're on the lesson difference of 2 squares. But how do you know this is not difference of 2 squares? You know this is not a difference of 2 squares because it has a greatest common factor. But here's the thing. How do you know that this is not a difference of 2 squares? Because I don't see perfect squares. 2's not perfect. Everybody agree? 2 is not a perfect square. It's not on the list. 98's not on the list either. They're not perfect. So here's the thing. You don't just throw up your pistol and say, you can't. Okay? You got to think of all the things you know. Okay? Does it have a GCF? Yes. So when we factor out a 2, what will I be left with? A squared minus 49. Are we finished? Always look back. What do we see here? Do we see a difference of 2 squares? Is a squared perfect? Check, check. Is 49 perfect? 7 and 7? Is it a difference? Check, check. We can. So what are we going to do with Bob? Bring him down. This guy we're going to take and split again. So first times first is a times a, and then we have plus 7 and minus 7. Okay. Any questions on, we take the GCF out first, and then we can take what we have left and break it again. Everybody okay? Yay or nay? Okay. Are we finding this easy? Okay. How about this one? Chord. Today's lesson is a difference of 2 squares. What do we have here? Adding 2 perfect squares. Did anybody actually try to make this m and maybe plus 8 and plus 8? Okay, well let's try this first of all. Let's think of all of our options here. So a lot of people in first block, they did this. And then they got to checking it, because we always check, right? Okay? And so when I said, you know, like we didn't even get halfway through it, and they were like, Miss Coins, I'm stuck. The check doesn't work. The check doesn't work. Did you check it to see that it didn't work? Anybody? Yay or nay? You got to speak to me. Okay. So how many actually had this to begin with? Okay, so most of us. So, well, you check it, and you get 8m here, and you get 8m here, and you get 64 here. But the problem is that you get your m squared, but you get a 16m in the middle. They don't cancel. Uh-oh. So then we maybe try to fiddle with it again. So that didn't work. So somebody said, well, let's try 2 negatives. Will a negative times a negative give me a positive? Okay, so this gives me m squared, the outer gives me negative 8m, the inner gives me negative 8m, and this does give me a positive 64 in the end, but the issue is that gives you a negative 16 in the middle. It don't cancel. And then, did anybody say, well, in order for it to cancel, you need one of each sign? Right? That'll cancel, right? Yes? M times m is m squared. The outer is 8m. The inner is negative 8m. It cancels. Check, check. Oh, it cancels. But what's the issue? This will give you negative 64. Oh. So here's the thing. How to get the last, how do I get a positive? I either use positive, positive, or I use negative, negative. But I also, at the very same time, need the outer and the inner to cancel. The only way for the outer and the inner to cancel, sign-wise, is to have one positive, one negative. So is there a way that I can get a positive on the end and get the middle to cancel all in the same problem? It won't work. You with me? That's why today's lesson is called a difference of 2 squares. Because with a difference, you will get them to cancel, and you'll get a negative at the end, and it does work. But with a sum of 2 squares, it won't work. Some things, they just don't work. So what's the answer to the problem? Now, if you leave it blank, prime. What does prime mean? It means nothing will go into it except 1 in itself. It can't be broken down. Like, for example, 11. Can 11 be factored? No. It's prime. The only thing that goes into it is itself and 1. It cannot break down. Okay, 7. 7 is prime. Does not break down. M squared plus 64 is prime. It does not break down. Okay, you might also see not factorable. Okay, you might see prime or you might see not factorable. Prime is probably the better word for the SOL. Okay, but you'll see one or the other. Does everybody understand if it's a sum of 2 squares? Even though it looks like it might work, please make sure you check because it won't work. Okay, it will not work. With the perfect squares? Yeah. That's why today's lesson is called, it has to be a difference. It has to be subtracting 2 perfect squares. Okay? How about we try this one? The question is how do you know when you're done? Let's take prime factorization for a minute. Okay? Let's take 12. In elementary school, you broke 12 down into 2 times 6. Agreed? Are you finished? Are you not finished? Can you break both of them down again? No. You can only break one of them down again. What do you do with this guy? You just bring him down, and then you can take this guy and break it further into 2 times 3. So the prime factorization of this will be 2 times 2 times 3. Do y'all remember that from elementary school? Yes? Or 2 squared times 3. So if we factored this guy, most of us put k squared times k squared, and we put plus 9 and minus 9. My question is, and everybody says, how does this problem relate to this problem? Okay, here is where we are right now with this problem. We broke it down into 2 pieces. My question is are you finished? Let's look at this guy. Can you do anything more with this guy? Is it a GCF inside here? No. Is there trinomial? No, it's 2 terms. Grouping? No, it's 2 terms. You with me? Okay, I'm just looking at the k squared plus 9. I'm not looking at this over here. Okay, is this a difference of 2 squares? What I'm pointing to right now. This right here is a difference of 2 squares. No, 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 no. And what do you know about if it's a sum? Lindsay asked. If it's a sum, it's prime. You can't do anything with it. So this is like our 2. So what do you do with the 2? You bring him down. Okay, you can't do anything with the k squared plus 9. You bring him down. But look over here. This is like our 6. What do we have with k squared minus 9? Is this the difference of 2 squares? K squared perfect? 9 perfect? It's a difference? So you can take this guy and break it down further. This is like your 6 that you broke down further. Do you understand? So you can break this guy down into k times k and plus 3 and minus 3. And it works. Do you understand that putting what we know that sometimes you can factor it once and then take it and go even further with it, okay? We've been looking at it right now of you take the GCF out and then go further of it. This one, you actually did a difference of 2 squares and then did a difference of 2 squares. You did it twice, okay? Harvey. This would be the actual answer. How many factors? 3. What's one of them? K squared plus 9, another, k plus 3, and k minus 3. It has 3 factors. Any questions on that? Everybody okay? So, you tried this one just to make sure that we have it. How about is this a difference of 2 squares? We don't know, because why? We're pretty sure it is, but why do we not know? Because it's not on our list. But just because it's not on our list, remember I said below 400, that's the ones you typically see. But you might see something bigger, so how do you check to see if 625 is a perfect square? Somebody said divide it by 2. Is that what we're doing? Well, what do I do to 81 to get to 9? I don't divide it by 2. I take it and take the square root of it. To refresh your memory, can I borrow yours? To take the square root of it, we're going to hit the second button, the blue button, and we're going to hit the x squared button. We did this one of our first lessons. Okay, and you get the square root, and then put in 625 and hit enter. Is 625 perfect? Yes, what is it? 25 times 25. So, good example, second x squared. Most of us were able to figure out this would be a squared, and then plus 25 and minus 25. Am I finished? No. Can this guy go further? No. What do we call him? Prime. Does not work. Okay? So if he just comes straight down, can this guy go further? Yes. Into what, Brandon? A times A and? Awesome. It works. Okay? I'm not going to do this as an example, but I just do want to show you. Let me go back to this for a second, and let me go back to, let me do 81 again. Okay? Difference of 2 squares? Yes. So this would be A times A and plus 9 and minus 9. Now my question is, are you finished? Or can you go further? Well, we know this guy's done, right? He's done. Prime. Okay? My question is this one finished? How many think he's finished? He's done. How many think he can go further? My question is he a difference of 2 squares? I see difference. Check, check. I see 9, perfect square. Is 8 perfect? No. So, can he go further? No, because if you broke him down and did A times A, it wouldn't be A. It would actually need to be A squared. Does that make sense? In order to be able to do it. Does everybody understand that he can't go further because A is not perfect? Okay. What if you had one that looked like this? And again, I'm just showing you really quickly, just giving you helpful hints. Y squared minus 9y. And I said factor that. Is it a difference of 2 squares? Why is it not a difference of 2 squares? I see difference. I see a perfect square. 9 is a perfect square, but y is not. So this is not a difference of 2 squares. Do you understand? Both pieces have to be perfect in order for it to be a difference of 2 squares. Okay, so then I had people that said non-factorable prime, non-factorable prime. Anybody else have a thought? I have a thought. I don't think it's prime. Oh, what, Colby? Does it have a GCF? What do they both have? Y. It's GCF. Okay, so this could be y minus 9. Am I finished, or could this go further? You're finished. Is this a perfect square? No. You with me? You're not done. Does everybody understand? In order for it to be a difference of 2 squares, this piece has to be perfect, and the whole piece has to be perfect. Okay, and it has to be a difference. But because of that y, it's not perfect. Okay, but it is a GCF. They both have a y. You can take a y out. Okay? All right. Let's review a little bit from yesterday. This is a grand problem. We are almost finished. Would everybody know what to do with this? How are we going to try to factor this to begin with? Does it have a GCF for everything? No, so you scratch that out. So how are we going to start to begin with? Why here group? Why do I hear group? Because it's 4 terms. This is what we did yesterday. So good review. So if I'm going to group this, everybody understand why I'm going to group? It has 4 terms. Okay. What can I take out of the first group? M squared. And we'd be left with 2m plus 1. Now somebody in first block said, like they try to take a 5 out of the second group. Anybody try to take a 5 out to begin with? The second group? And then what did you notice? Well, you could notice that you didn't get the biggest, that you could go again. Or you notice that your 2 groups didn't match, right? Did you figure that out? So don't forget, did anybody use my little trick yesterday that if you don't know what to take out, you know what has to be in this group. If this is 2m plus 1, then you know this group has to be 2m plus 1. And somebody in first block said, in order to get a 1 from the 25, what did I have to take out? I had to take out the whole 25 to get a 1. Or you could say, in order to get a 2 from the 50, you'd have to take out a 25. Okay? And you can kind of work backwards. Did anybody use that last night? Did you work backwards through some of them to make your groups match? Okay? From there, you throw it in a pot. What are we going to put in the pot? M squared minus 25 times quantity of 2m plus 1. Am I finished? No. Can this guy go further? No. You look, and everybody says, I don't know how if he can or if he can't go further. Does 2m plus 1 have a GCF? No. Is he a trinomial? No. Does he have 4 terms? No, he's got 2 terms. Is he a difference of 2 squares? No. I mean, you go through your list, he's not any of the above, so he just comes down. But this guy is a difference of 2 squares. And he can go further into m and plus 5 and minus 5. How many were able to get that? Okay? Okay. Last one. Factor that for. This is not a difference of 2 squares. It looks like it. So please don't get going. You got to really, really think about these. I mean, most of the time you look at a trinomial, you go, oh, trinomial. You with me? And most of the time you look at 4 terms there, you go, oh, grouping. You with me? But please don't go too quick because they throw some tricky ones out there. And this is a tricky one. And most people, how many will admit, in 3 weeks from now, when we haven't gone over this, and I throw this up on the board and I say factor it, how many will try to use a difference of 2 squares? How many would admit that to me? Okay, and I would say 3/4 of the class, at least, would do a difference of 2 squares. Okay, but it's not, because you can't, I agree with Colby, you cannot do half an A and a half an A. Okay, this is perfect, but the A is not. So everybody says, well, it's prime. No, it's not prime. What else do we know? GCF. What can go into both? 4A. They both have a 4 that can come out, and this has 2 A's, this has 1 A. You can take an A out. And when you do that, you're left with A minus 4. And my question is, are you finished? So back to Lydia. Can this go further? Is this a difference of 2 squares, or is it finished? It's finished. This is perfect. Some people would try to go further with this and go down, and Sean was back there thinking, he's like, am I done? Am I done? Were you thinking, could it go into A minus 2 and A plus 2? Could you go further? But you can't, because I agree with Colby, can't do half an A and half an A. Okay? A is not perfect. It has to be A squared, or it has to be A to the 4th. What could be another perfect one? A to the 6th. A cubed and A cubed, right? Because when you multiply powers, you add the exponents, okay? So you're done. It's a monomial times a binomial, okay?